This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
In this video, you'll learn how to pick and use a good method for solving a system of equations. A system of linear equations is a group of two or more linear equations, and a solution to the system is a point where all the lines in the system intersect. We write the solution as an ordered pair, x, y. A system of linear equations can be solved graphically or algebraically. We can graph the lines and see where they intersect, or we can solve the system using substitution or elimination. Let's try a few examples together. For our first example, we need to solve the system y equals negative 4x plus 3 and y equals x minus 7. Since both equations here are written in slope-intercept form, let's graph them to find the solution. We'll graph both lines and see where they intersect. Remember, in slope-intercept form, the equation y equals mx plus b has slope m and y-intercept b. That means for our first equation, our y-intercept is 3. Let's graph it. And our slope is negative 4, or negative 4 over 1. So starting at the y-intercept, we'll move down 4 units and to the right 1 unit. Now we'll plot a point and connect the 2 points with a line. So here is our graph of y equals negative 4x plus 3. All right, now we'll graph our second equation. The y-intercept is negative 7, and the slope is 1, or 1 over 1. So starting at y equals negative 7, we'll move up 1 and to the right 1, plot a point, and connect the points with a line. Now we have our graph of y equals x minus 7. Great! Do you see where the two lines intersect? Right here at the point 2, negative 5. So the solution to this system is the point 2, negative 5. Awesome work! Let's try another one. How should we solve this system? X equals negative 6 and x plus 2y equals 8. We have the equation of a vertical line and the equation of a line in standard form. Those are both pretty easy to graph, so let's graph this one too. The first equation is the vertical line for which all of the points have an x-coordinate of negative 6. So here's our graph of x equals negative 6. The other equation, x plus 2y equals 8, is written in standard form. So to graph this line, let's find the x and y intercepts. To find the x-intercept, we'll set y equal to 0. We get x plus 2 times 0 equals 8. And simplifying, we see that x equals 8. So let's plot the point 8, 0 on the graph. To find the y-intercept, we'll set x equal to 0. We get 0 plus 2y equals 8, which simplifies to 2y equals 8, or y equals 4. So let's plot the point 0, 4 on the graph. Now we can connect the two intercepts with a line. So this is the graph of x plus 2y equals 8. Great, we have both lines graphed, so now we can solve the system. Where do the two lines intersect? At the point negative 6, 7. So the solution to this system is negative 6, 7. Let's look at another problem. Here we need to solve the system y equals 5x minus 12 and negative 7x plus 6y minus 20 equals 0. Since y is already isolated in the first equation, let's use substitution here. We can just take the expression that's equal to y in the first equation, 5x minus 12, and substitute it for y in the second equation. We get negative 7x plus 6 times 5x minus 12 minus 20 equals 0. Let's solve this equation to find the value of x, the x-coordinate of our solution. Using the distributive property, 6 times 5x is 30x, and 6 times negative 12 is negative 72. Now we have negative 7x plus 30x minus 72 minus 20 equals 0. Combining the like terms, we get 23x minus 92 equals 0. And solving for x, we get x equals 4. So we have the x-coordinate of the solution, but how about the y-coordinate? If we substitute 4 for x in either equation and solve for y, we'll find the y-coordinate of the solution. Let's try it with the first equation. We get y equals 5 times 4 minus 12, which simplifies to y equals 8. Great work! The solution to this system is the point 48. How about we work out one last problem? In our last problem, we need to solve the system negative 3x plus 2y equals 20 and negative x plus 5y equals negative 2. Since both equations are written in standard form, it'll be easiest to use elimination. We want to eliminate either the x's or the y's, and then solve for the remaining variable. If we multiply the second equation by negative 3, the x's in our two equations will have opposite coefficients, so when we add the equations together, the x's will be eliminated. Multiplying the equation negative x plus 5y equals negative 2 by negative 3, we get 3x minus 15y equals 6. Now we'll add the two equations together. Negative 3x plus 3x is 0. 2y plus negative 15y is negative 13y. And 20 plus 6 is 26. So negative 13y equals 26. Solving for y, we see that y equals negative 2. Now we'll substitute negative 2 for y in either equation to solve for x. Let's use the first equation. 2 times negative 2 is negative 4. So we get negative 3x minus 4 equals 20. Solving for x, we see that x equals negative 8. That means the solution to this system is the point negative 8, negative 2. Well done! When you're solving a system of equations, remember that you can pick whatever strategy seems easiest: graphing, substitution, or elimination. Now go try some out on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.